Hello viewers, today we are going to demonstrate the construction of different logic gates using universal NAND gate. NAND gate is a digital gate using which we can construct other logic gates such as AND gate, NOT gate, OR gate and so on. Let's now see the operation of NAND gate. When both of its inputs goes high, then only the output of this gate becomes low. Otherwise, the output remains in logic high state. Now we can construct a NOT gate or inverter using NAND gate if we tie its both input together. We can build AND gate using two NAND gates as shown in the screen. At the left hand side we can see the functionality of AND gate. And at the right hand side, the same functionality is reciprocated using two NAND gates. Similarly, we can construct OR gate using three NAND gates as we can see in our screen. Here, a logic OR gate is constructed by three NAND gates, which shows exactly the same functionality as conventional OR gate. Today we are going to perform the experiment with the help of a trainer kit as we can see in our screen. Let's see how many inbuilt sections are there in this trainer kit. The first section in the left corner of this kit is digital logic input section. Here the red and black connector are used as logic high and logic low input. The next section is digital logic output section, which is placed at the right side of the trainer kit. There are 4 LED indicators in this section using which we can check the logic state of digital signal. 8 dual input NAND gates are placed at the middle position of this kit. Here we are using 7400 IC. In the extreme right side of this kit there is an external breadboard attached additionally, using which we can perform the experiment with the help of an external IC. The inbuilt DC power supply section is placed just at the up middle position of this trainer kit. Now let's check the functionality of each inbuilt section of this trainer kit. First we shall check the DC power supply section. To do this we are using a multimeter in DC 20 volt range. We shall connect the multimeter's common probe to the ground terminal and other probe to the plus 5 volt terminal of the power supply section. Now switch on the trainer kit. Here we are observing plus 5.16 volt in multimeter screen. So we can say that this section is working properly. Similarly, we shall check the functionality of digital logic input section using a multimeter in DC 20 volt range. Now let's connect the multimeter's common probe to the logic low input and other probe to the logic high input of digital logic input section. Here we are observing that plus 5.24 volt at multimeter screen. So this input is working properly. In the same way we shall check the rest of the input. We are observing here for each section we can get the same result at multimeter screen. So this section is working as expected. To check the functionality of digital logic output section, we shall connect this section to digital logic input section via patch cord. First we shall connect the logic high input and observe that the connecting LED is glowing. Now we connect the logic low input. In this case the connected LED is not glowing. So we can say that this section is functioning correctly. Let's verify the truth tables of NAND gate. Here we are assuming the yellow connector of NAND gate as A, black connector as B and the red connector of output as Y. Now connect the output of first NAND gate to the digital logic output section via patch cord. And both the input of this NAND gate to logic low input of digital logic input section. Turn on the key. Here we are observing that the connected LED at the output is glowing, so the output is at logic high state. Then we shall change the logic state of NAND gate input to logic low and logic high state. The output LED is glowing, so output is at logic high state. Now change the logic state of NAND gate's input to logic high and logic low state. Here also the output LED is glowing. Lastly, we shall connect both the inputs of NAND gate to logic high state. Here we can observe that the output LED is not glowing, so it is at logic low state. Finally, we can conclude that the NAND gate is working properly. Similarly, in this way, we can check rest of the NAND gates. NAND gate is a universal gate, using which we can construct other logic gates like AND gate, OR gate, NOT gate, etc. Now we shall construct a NOT gate using NAND gate. For this purpose, first we shall connect the output of a NAND gate to the output LED indicator. Connect the inputs of this NAND gate with each other by patch cords. Now connect any inputs of this NAND gate to logic high input. Turn on the key. Here we can see that at the output the connected LED is not glowing, that is the output is at logic low state, but the input is at logic high state. Now we shall change the input to logic low state, and we can see that the output is now at logic high state. So this NAND gate is working as a NOT gate. Let's construct AND gate using two NAND gates. Connect output of a NAND gate to the output LED indicator. Connect the two inputs of same NAND gate with each other by patch cord. Connect this point to output of another NAND gate. Now connect the input of this second NAND gate to logic low terminal. Turn on the key. Here we can see that the output is at logic low state. If any one of two inputs is at logic low state and the other one is at logic high state, then output will still be in logic low state. Finally, if both the inputs are at logic high state, then the output will be at logic high state. Hence, combination of two NAND gates connected this way acts as AND gate. Now we shall construct OR gate using three NAND gates. For this, we shall connect the NAND gates as shown in the connection diagram. We have completed the connection, hence let's verify the truth table. If both the inputs are at logic low state, then the output will be at logic low state. If any one of two inputs is at logic low and other is at logic high state, then the output will be at logic high state. In the combination of both the input at logic high state, the output will also be at logic high state. Similarly, we can construct other logic gates like XOR, NOR, etc. using NAND gate. The complete operation manual of this video is attached in the description box. If you really like this video, then please hit the like button, subscribe our channel for more videos like this and press the bell icon to get notification first. Feel free to visit our website www.kalpanascientific.com at your convenience for any product related information. Thanks for bearing with us. Let's meet in upcoming video of this tutorial series. Till then, bye bye.